Good morning, everyone. Myself G. Mallikarjuna. I am from Triple E department. Today, I am explaining the topic is extrinsic semiconductors, P-type and N-type semiconductors. Introduction to extrinsic semiconductors. Extrinsic semiconductors are materials that has doped with impurities to modify their electrical properties. This doping introduces charge carries that exchange conductivity behind that of intrinsic semiconductors. The two primary types of extrinsic semiconductors are p-type and n-type, which each with distinct characteristics. What are p-type semiconductors? P-type semiconductors are created by doping a semiconductor with elements that have fewer valency electrons. Typically, their common dopants for p-type semiconductors include boron and gallium, which create holes that act as positive charge characters. In p-type materials, the majority of carriers are holes, while electrons are the minority characters. Uh, Mechanism of p-type doping: when a travalent atom is introduced uh, into a semiconductor lattice, it forms covalent bond which leaves one bond incomplete. This incomplete bond creates a hole which can accept an electron, effectively allowing from positive charge conduction. The movement of holes through the lattice constitutes the flow of current in p-type semiconductors. Properties of the p-type semiconductors: p-type semiconductors have higher uh, electrical conductivity compared to eccentric semiconductor due to the presence of holes. They typically exhibit an higher concentration of holes compared to electrons, leading to their distinct electronic properties. The energy bond structure shows the ferrium level is closer to the valency bond in p-type materials. What are n-type semiconductors? N-type semiconductors are formed by doping a semiconductor with elements that have more valency electrons, usually 5. Common dopants of n-type semiconductors include which include extra electrons in the materials. In n-type materials, the majority charge carriers are electrons, while holes are the minority carriers. Mechanism of n-type doping: when a benevolent atom is added a semiconductor lattice is formed for covalent bonds and denotes an extra electron. This extra electron becomes a free charge carries, increasing the conductivity of the semiconductor. The flow of these free electrons through the lattice contests the current in n-type semiconductor. Properties of n-type semiconductors: n-type semiconductors exhibit higher conductivity than eccentric semiconductor due to the abundance of free electrons. The concentration of electrons is much higher than the holes, resulting in distinct electrical characters in the energy band structure. The Fermi level is situated closer to the conductivity bond in the n-type materials. Comparison of p-type and n-type semiconductors: p-type semiconductors have holes as the majority carriers, while n-type semiconductors have electrons as the majority carriers. Both type can be used in electronic devices, but they serve different roles in semiconductor junctions, like donations and transitions. The choice which p-type and n-type depends on the desired electrical characteristics. for specific applications. Applications of extrinsic semiconductors. P-type and N-type semiconductors are crucial in the form of fabrical of diodes, transistors, and other electronic components. They are used in solar cells, LEDs, and integrated circuits, forming the backbone of modern electronics. The combination of p-type and n-type materials allowed by creation of p-n junction, which are essential for electronic devices. A conclusion: extrinsic semiconductor significantly exercise the electrical properties of semiconductor materials through doping. Understanding the differences between p-type and n-type semiconductors is vital for the design and application of electronic devices. The ongoing advantages in semiconductors technology will continue to shape the future of electronics and materials since. Thank you.